Physics. Physics is one of the most enjoyable branches of your JEE study. It's one of the most logical and simple branches. What exactly is physics? It is the study of the matter and its motion through space-time and everything that's related to these, such as energy, force. Basically, it is the general analysis of nature. We want to understand how the world and the universe behaves, and so we try and derive the principles of physics. Physics has, by and large, 5 major parts. First major part is mechanics. It deals with the study and motion of physical bodies and the laws of motion. Next, we have thermodynamics, which deals with heat and its transfer and the laws of heat transfer. Then electricity and magnetism, which we all know about. After all, our world runs on electricity. Waves and optics deals with the various optical illusions and the travel of light. Modern physics is about the cutting-edge physics research that happens now about various particles which are being investigated even as we speak. Let's go to mechanics. Mechanics is essentially the study of the motion of simple particles. It is the branch of physics dealing with the study of motion. No matter what your interest is in science or engineering, mechanics will be important and will be useful to you. Motion is, after all, one of the most fundamental ideas in all of science. Broadly, mechanics has 2 areas: kinematics, which deals with the description of motion; dynamics, which deals with the causes of that particular motion and why those bodies move the way they do. Briefly, let's go through the various areas of mechanics and its scope in IIT JEE. Firstly, we have relative motion, the motion of one body with respect to another. If I'm sitting in a train and moving, the world appears different to me. It appears to be moving behind. The application of vectors, and that's especially important in relative motion. Errors. How do we measure things? What are the various problems that we can face in physical experiments, and how do we take them into account? Significant digits are related to the same concept. Friction. After all, we walk due to friction. How do these frictional forces work? How do we make use of them to build machines? Systems of strings and pulleys and their various interaction in terms of forces. How can I pull up such a big heavy body using friction, strings, pulleys to try and multiply my force? Springs and their laws. How does a spring work when compressed? How much energy is stored there? How does a body move and how fast will it move when it's released from a spring? Collisions, momentum and energy conservation, which help us deal with both the motions of simple bodies and the motions of complicated bodies and their interaction. If we have 2 big bodies coming together which interact in a complicated manner, it's difficult to try and see the laws of physics as applied to each particle. In that case, we use general principles like momentum and energy conservation, and the concept of center of mass to reduce big bodies into simpler point particles to which the laws of motion can then easily be applied. We also have finding the moment of inertia for composite bodies, which relates to rotation and how the laws of rotation should be applied. The proper application of energy and angular momentum conservation in these kinds of problems, where you might have strangely shaped bodies which are moving and rotating. It's important to make sure that you apply the laws correctly without making any particular mistake or neglecting any component of the momentum or energy. Simple harmonic motion, that is regular periodic to and fro motion, for instance the motion of a pendulum. Energy conservation and the concept of restoring force. We also have hydrodynamics in this, the buoyant force, Bernoulli's principle, and mechanics with related to physical bodies in terms of the stresses and strains that happen. What are the various elements in mechanics and how are we going to study them? We start off with kinematics. Kinematics is the description of the motion of a simple particle. We'll then move on to the laws of motion, which describe how these simple point particles can be made to put into motion and can be stopped. Newton's laws, of course. We then deal with more extended bodies and use the concept of center of mass to reduce the study of those extended bodies to the study of point particles, which we already know about. We then move on to more general concepts, work, power and energy, which allow us to derive some useful conservation principles. That is, we do not need to apply the laws of physics to each particle, but we can still make statements about what their initial and final states will be. We'll then go on to deal with rotational motion. That is a body which can be spun about itself, and in that case we'd have to take into account the shape, etc. of that particular particle. Finally, we'll deal with simple harmonic motion, to and fro periodic motion, its time period, etc. dealing with the basic mathematics that we need to understand physics. Fundamentally, we have to talk about vectors. They are the key to the proper understanding of physics, and everything that we'll deal with in physics is derived on this concept of vectors. One must have a sufficient knowledge of calculus, solving these equations, deriving the relations among the various physical quantities, and then reaching the accurate, correct solution. One should be well versed with how the addition, multiplication rules of vectors apply, how we can find the angles between the different vector quantities, their dot products and cross products, as well as the standard rules of differentiation and integration formulae, because we'll be using them in almost numerous problems in physics. We should absolutely not ignore these topics, because even though they are the most basic topics, questions on almost any chapter may well be based on these concepts, and the study and clarity in these concepts will help us easily go through the remaining chapters.